people, in this video we are going to be talking about how to graph tangent of x, okay? In our class we haven't gone over this, so this is going to be an introductory video. If you catch a mistake, please let me know where the mistake occurs so that way I can learn from my mistakes and then you can learn from my mistakes as well. All right, let's get started. One thing that you need to know is your tangent values. We will go through them really quickly on how to develop them. Remember that all of our values for graphing are coming from our unit circle, specifically for, technically 5 points. So there's 1, 2, 3, 4, 5. And we need to know what these values are, where these points are located. So the first one here is 1, 0. This is 0, 1. This is negative 1, 0. This is 0, negative 1. Now, another thing you need to know is what tangent of x is. So tangent of x is sine of x over cosine of x. So let's develop the values that we need. Again, I said we need 5, but technically 4 of these. So the first one we need is we need tangent of 0, and we need tangent of 2 pi. So again, these two are the same, so that's why I say technically 4, but technically 5, because these two values are the same. After that, we need to know what tangent of pi halves is. We need to know what tangent of pi is, and we need to know what tangent of 3 pi halves is. Okay, so again, sine over cosine. So we have tangent of 0. We're saying sine over cosine, and then just so you guys remember or recall, first value is cosine, the second value is sine. So when we're saying sine over cosine, this one is cosine, this is sine. So cosine is 1, sine is 0, so tangent of 0 is 0. So that means tangent of 2 pi is 0 as well. Tangent of pi halves, we are doing sine over cosine. So sine is 1, cosine is 0. This is undefined. Tangent of pi, again, sine is 0, cosine is negative 1, so this is 0. And then we have tangent of 3 pi halves. So tangent of 3 pi halves is sine over cosine, so sine over cosine, that once again is undefined. So I'm going to do just a brief sketch here of the information that we know. So we have 0, we have 2 pi, and maybe I shouldn't do them as points. Let's do little dashes instead. So here's 2 pi. We have, this is pi, this is pi halves, this is 3 pi halves. Okay, so what do we know? We know that tangent of 0 is 0. Okay, so that's okay. Tangent of 2 pi is 0, so my points were originally okay. Tangent of pi halves is undefined. This is where you have your first asymptote. If something is undefined, you have a vertical asymptote. And remember, an asymptote is an imaginary line that one shall not touch but get infinitely close to. Okay, so we cannot touch. So we call this line a no touchy-touchy line. Okay, then we have tangent of pi. Tangent of pi is 0. And we have 3 pi halves is also undefined. So what you're going to notice about graphing tangent that is really different than graphing sine and cosine is that you have these asymptotes. Okay, so let's go ahead and continue back here. So I have negative pi halves. I have negative pi, negative 3 pi halves. And again, one thing that you're going to notice is, I guess not one thing, another thing that you're going to notice about graphing tangent is that when you're graphing the parent function for sine and cosine, you typically go towards the positive x values. Whenever you're graphing sine and cosine, excuse me, whenever you're graphing tangent, you're actually typically going to be working with positive and negative values. So typically what you're going to see is a positive pi halves and a negative pi halves because we have the origin in there and it's a little bit easier for us to graph. So that's another difference between graphing sine and cosine. A third difference is just the way it looks. So if you continue a sine wave in both directions, if you continue a cosine in both directions, they look pretty much similar, except that the cosine is shifted and the sine is shifted. So if you shift a cosine wave, it does eventually line up with a sine wave. Again, we're talking about the parent functions. Tangent is just completely different. Tangent is on the weirder side. And a fourth difference I want to mention is for sine and cosine, when we were graphing them, we only used 1, 2, 3, 4, technically 5 points. For a tangent, we're actually going to go and dive into quadrant 1 in order to find out what are other points. So far we have a lot graphed, but we don't technically have any of our function graphed. Okay, we have asymptotes graphed, we have 2 points. And again, just a reminder, typically what you're going to see for one period of, I guess you can almost say half a period, but one tangent curve or wave, one tangent graph, is you're going to notice this. So you're going to have 2 asymptotes, so pi halves, negative pi halves. And then what you're going to see is we also need to know where our points are, so 1 and -1. So what you're going to see is this, and it's wonderful. So going to quadrant number 1, you're going to ask yourself, at what value does tangent equal 1? And so that value is at pi fourths. So at pi fourths, tangent, actually let me write this here. I started to write it somewhere else, but let me continue here. So another point that we need is tangent of pi fourths and tangent of negative pi fourths. So we need it in both directions. Again, what is tangent? Tangent is sine over cosine. What is sine of pi fourths? And what is cosine of pi fourths? And that is rooted to 2. I'm thinking Mr. Andy from the office here. And that just equals to 1. So tangent of pi fourths is 1. And then tangent of negative pi fourths is 1. But I'm thinking back to the all students take calculus. Negative pi fourths is located in the 4th quadrant. So it is here. So we have all students take calculus. That means our answer or our exact value of tangent of negative pi fourths is a -1. So tangent of pi fourths is 1, tangent of negative pi fourths is -1. And those two are extremely important as well. Now notice that pi fourths is half of pi halves. Again, half of pi halves is pi fourths, and half of the distance of negative pi halves is pi fourths in the negative direction. So if you have a positive tangent graph, it's going to increase from the left to the right. I'm also thinking of Mr. John Travolta. So if you remember Mr. John Travolta, it kind of looks like that a little bit, okay? So if you're in my class, you know the John Travolta reference. If you don't worry about it. So we are going to say, here's 1, here's -1. At pi fourths, positive pi fourths, tangent is 1. And at negative pi fourths, tangent is -1. So we're going to have a curve that goes off to infinity on the right-hand side and then goes off to infinity on the left-hand side. So again, you have asymptote at pi halves, you have asymptote at negative pi halves, and then you have your point at 1, you have your point at -1. All right, let's go ahead and graph this. So this is going down to the asymptote, and then this is going to increase to that. Now, there's going to be a little bit of a bend here. I don't know if you can see that. Try to make it as smooth as you can. Now, you can't touch your asymptote line. And that's going to continue over and over and over again. So here's half, half. Here's 1. And again, here's your asymptote line. And if you end up with a reflection, your points switch off of the midline. Now, I do want to mention in tangent, I don't even know what number we're on, the difference between sine and cosine and tangent. For tangent, there is no maximum and minimum values, okay? Because we are going off to infinity all the way up, all the way down, we cannot assign a maximum or a minimum value. They increase to infinity and then beyond. All right, you guys, this is going to be our video part 1 on how to graph tangents. So this is your parent function. In the next video, we're going to be talking about how to translate, how to transform these. Given an equation, how do you even graph these? Shifting up, down, left, right. Go ahead and continue to our next video. I hope you enjoyed this video. I hope you learned a lot. Please like, share, and subscribe. I appreciate you watching my videos. Thank you so much. Have a great day.